Hey, Marcus House with you here. Welcome to this episode. Today, as promised, we are going to cover the coding of the previous mission that we did last week. If you want to see the mission before watching how all of the code here goes together, you can click the tile here in the top right now. And yes, basically to sum up that episode, what we did was send an entire moon return mission using just the Kerbal operating system mod, and we even managed to come and land our boosters down on the vehicle assembly building and the launch pad. Now, the script that you are seeing here is available in the description. You can download that along with the craft file, which you can download from last week's episode, so you can try all of this together. You may find that you need to slightly tweak some numbers and things like that, because I've been playing with the script just a little, and slightly different re-entry profiles, especially for the booster landings, just require some tweaking sometimes to get it absolutely perfect. Now, I will just start off here by saying that I'm not a massive Kerbal operating system expert. I haven't been doing this for years. I've only really been recently learning how to put all this sort of stuff together. If you really want to learn this stuff well, I highly recommend going to the Kerbal operating system documentation and learning all this yourself. And obviously my code here could possibly just provide some inspiration, and you can at least see how I'm achieving some of the things I'm doing in this video. So there's basically three files here. What we're looking at right now is the bootloader script. This goes straight into the ships/script/boot folder here. And basically it just copies two other files, the main program as well as a function library. This functions library is here basically, so it first loads this one and then it loads the main Mun Lander KS file, which is the main program here. So it loads all this in. This does a big loop through all sorts of stages and steps and that sort of thing. So apart from that, all this bootloader does is just prints out a few little messages there to help people start the program that aren't familiar. So at the top of our main program here, I've just got a function which really just applies to this one program, which is just to update readouts. You can see we're printing out the step, and we're printing that at an exact position in the terminal, and we're also doing some other little readouts there as well as a general output message. We then basically include our main functions file and we do a clear screen just so that everything's nice and clear when we first start. You can also do this auto open terminal here if you want the terminal to auto open. I actually turned that off. Next we have basically a whole heap of step variables, and we can switch these out depending on which part of our script we are testing. So you can see it's currently set to launch, but if we wanted to quick save and then actually test out the booster return, we can manually just uncomment this and do the booster return, and I'll be showing that stage a little later on. We then have other global variables here, such as the looping variable, which I use to just basically loop the main program. So basically what it's going to do is it's going to loop over this entire massive loop all the way down here until I manually call an end to it. So you can see right in this step end, I am setting the looping to false, which basically means the program ends. It breaks out of that loop, and that's the end of the program down here on line 533. Now, if you are new to Kerbal operating system, what you'll notice a lot of people do is they'll do these locking commands. So you'll see here I've got a variable called throttle, which is basically the throttle. We're setting that to 0, but you'll see I'm locking the throttle to that variable name. So basically all I need to do is update that variable at any time through the script, and that throttle will actually be locked. And the same goes for ship direction and ship pitch, which I've got here. Now, sometimes in this script I do unlock the steering and lock it in a different way, but basically that is used by some of our global functions that do all sorts of interesting things here, such as updating the hover commands to steer ourselves in certain directions. So all of that applies to this, the steering direction and steering pitch. We have some other variables such as our target apoapsis around Kerbin. We also have a boolean here which states basically whether our fairing has deployed or not. We have a target body, which is obviously the moon. We have our general output message, which we can set at any time to go up into our update readouts function there, which is really quite handy. And you'll notice here shortly that each tick around our loop we do an update to that readout, so that's really quite useful. We also have a target moon vessel, which is our far side tower ship. That's where we're picking our landing location. And then we have our landing target on the moon, which is basically a geoposition lat long set of coordinates, which takes our target moon vessel and basically adds or subtracts a small amount just on the latitude. That way we can just make sure that it lands close by. So 0.006 seemed to be quite a good mark there. Now for the booster return, I've got a few variables set up here, a few examples. You can see here I've just got this commented out, but we have the vehicle assembly building roof, so we've got a landing target for that and the launch pad here as well. With each of those, so again we need a geo position lat long, which I've got hard coded. You can basically get a reading of what they're going to be, and you need an altitude as well, which I'm using just to perfect the touchdown speed really. So you can really just comment one of these sets of coordinates out and leave the other one active, and that will define where your booster is going to attempt to land. You can see here the booster landing altitude for the vehicle assembly building is just a bit higher. It's 220 meters off the ground, whereas the launch pad was at around 115 meters. After this we have our default throttle locking and our steering locking to that heading, and then we have our main massive loop here, which is basically the entire body of the massive script. You can see we've got it set to true by default, and it's going to loop here until we set looping to equal false. It's going to rotate around and around here. And the first thing it's going to do in each loop is update our readouts with some of our special messages there from the top. So that will then output that into the terminal. And then we just basically have a whole heap of if statements which basically let us jump into each step of the process, and each of these steps will loop around over and over again, not executing any other step as long as they have got different names. And yes, we just basically go through each step one at a time. So this hopefully makes it very easy to see from a logical point of view. So the first step being the launch, it'll loop over there until that's finished, then it will go into the initial climb, and then it will go into the gravity turn step. And again, you can reset the step variable at the top just to test each phase. So the very first step here, we're doing a stage, we're turning the brakes off, stability assist off, lights off, RCS off, we're setting the throttle to 1, which is basically full throttle, and then right after that we're setting our step to the init climb step. So that will then mean that on the next rotation, we are now in this rotation here. We're going to loop through this init climb phase, and the ship is going to wait until it's got a vertical speed of greater than 80 meters per second, and then it's going to switch the step to gravity turn. Once we go into gravity turn, every 0.2 of a second, we are just going to change the pitch of our vessel to itself minus 0.2 degrees. Now what that means is every 200 milliseconds the ship is just going to slowly pitch down from 90 degrees, which is pointing straight up, slowly down towards 0 degrees, which is pointing straight at the horizon. So if our ship apoapsis is greater than 70 kilometers, we're going to set our throttle to 0.2, which is 20%. And then if it's above 80 kilometers, then it's going to switch the throttle off and switch to the next weight curb and circularize step. So you just need to make sure that your Kerbal operating system ship part has got the correct bootloader selected, and then we can just run Mun Lander, and then from up in the terminal we can see that our step is currently set to initial climb. So obviously it looped through that very first launch step extremely quickly. As soon as we pass 80 meters per second in our vertical climb, it starts slowly pitching over 90 degrees on the nav ball, and it's just incrementing itself. You can see there at 0.2 degrees every 0.2 of a second. Now it will continue this pitch basically until our apoapsis gets above 70 kilometers, and then it's gonna throttle down to 20%. So you can see there in our terminal we're getting constant feedback on our step, our steering direction, our pitch and our ground speed, which is quite handy diagnostic information. So the apoapsis is just getting above 70 kilometers there. Now you can see it's throttled right down to 20%. And I did this basically because I wanted a clear apoapsis of around 80 kilometers, and I also wanted it to slowly turn while it was still in the atmosphere without actually ending up rotating due to atmospheric drag. As soon as we hit that 80 kilometers, you'll see we hit the next step, which is weight curb and circularize. Now, if we go back to the script at this point, this is where we left off, you'll see here that what we first did was deployed the fairing. So we have a quick boolean there just to keep track of whether we've already deployed it or not. And also we want an altitude greater than 55 kilometers, otherwise we'll keep burning up there. So we have that little part there. We then basically set our ship pitch to 0, which means it's going to lock to the horizon. Remembering, of course, that ship pitch variable is tied to the lock steering to heading up here, so it's going to automatically keep pointing that ship down. At 5 seconds to apoapsis, we throttle up full and we switch to the curb and circularize And we take a quick reading of our target apoapsis, which is basically our current apoapsis plus 1500 meters, so it should be just a little greater than what our current apoapsis is. So once we are in this step of the process, there's several things we need to do to circularize well. First of all, if our ship apoapsis is greater than 20,000 meters, then we want to throttle right down just to get the accuracy better. Otherwise, we want to obviously throttle up full thrust, which is 1 here. So that again is full throttle. If our ETA to apoapsis is greater than 500, probably means we've passed the apoapsis, in which case we should pitch up. And if it is less than that, then we should pitch down. So that's going to hover the vessel, and you'll see that the vessel points up and down as it's trying to keep the apoapsis right on top of itself. So as soon as our target apoapsis is less than our current ship apoapsis, then we set our throttle to off and we go into our deploy stage, which is obviously setting a whole bunch of action groups. Action group 10 there is our solar arrays. We're then just going to wait for 4 seconds before we run action group 9, which is our antennas. So we'll switch our antennas on there. That's the communications. Wait a few seconds, we'll drop the booster, so that's staging, and then we're going to stage again after a few more seconds, engaging the engines, set our throttle up to 0.2 and wait for a few seconds just to get away, and then we're going to jump into our warp to moon injection. So the warp to moon injection is just basically saying, yep, jump into time warp, time mode, which is basically rails, which basically means we're not in physics warp. Set the warp value to 3, and then we hop into our wait mun inject step. So just watching all that execute there now, you can see we drop the fairing, our throttle is now set to 0, and it's basically then just going to wait until there's only 5 seconds before hitting the apoapsis marker. So you'll see the vessel pitching up and down here just to keep that time to apoapsis quite low, as close to 0 as it can. So that gives us quite a good circularization when it's finally finished. Just as we get close there, you'll see it throttles right down to 20% and then cuts entirely just as it circularizes. Then of course we deploy all the solar arrays, the antennas have come out, and then after we've separated, we jump into that time warp to wait for the appropriate time to begin our moon injection burn. Basically what's happening here is I'm doing a bunch of vector calculations to figure out when our phase angle is correct to begin our burn. There's probably a better way to do this. I'm sure there's probably a better way to do this actually. What I'm doing here is calculating the phase angle to the moon based on where we're currently at around our orbit, and I'm doing this interesting weird moon difference calculation which tries to figure out if I'm coming towards the target or not. There's probably a better way to do that, but as soon as we determine that the phase angle is correct, we basically jump out of time warp, and here we basically wait until our time warp has settled. And then after that, we wait for 8 seconds, which is basically enough time for the vessel to turn retrograde, and we throttle up to 1, which is full throttle, and we switch to the moon injection burn phase. So this is fairly simple, this step of the process. Obviously we want to burn until we get an encounter with the moon. Basically as soon as we get that encounter, we're going to throttle down, because obviously we're already throttled up. So as soon as we get the encounter, we're going to throttle down to 0.05 on our throttle, which is a very low throttle. And then that's basically going to allow us to just slowly wait until our periapsis around the moon is less than 20,000 meters. Of course, then we're going to set the throttle to 0, we're going to wait for a little bit, and we're going to jump into a time warp until we get into the moon sphere of influence, which is this last little if condition here. So basically, if the body name is the moon, then we want to step over to the warp to moon encounter step there. So while all this is happening, I've got a general output here, which is just telling us what our current orbit transition is. So that's then getting updated each time, and it's showing what our current transition is. So it'll be it'll start off being final, and then it'll finally switch to encounter. So once we've hit the encounter, we switch over to this step. We then again switch our time warp down to 0, and then we're going to do a small adjustment here to bring our ship periapsis down to 10,000 meters. Now what we're going to do is check whether we need to do a radial in burn here, which is the case if it's greater than 10,000, or a radial out burn. So if it's greater than 10,000 radial in, less than 10,000 radial out. So this is actually a steering lock, so this invalidates our heading lock that we had earlier, but you'll see here I've got some common functions. So if I want to do a radial in or a radial out direction, you can just basically call these common functions that I've got in my little functions library. They're very handy. Basically, the vector radial out is just the opposite, which you can multiply by -1. If you multiply a vector by -1, you get the opposite direction, which is interesting. So once the steering is locked to point to either radial in or radial out, we're going to wait for 10 seconds so the ship can actually rotate correctly, and then we're going to switch to the adjust moon periapsis step, which is actually the burn itself. So we're just keeping track of our periapsis here in our general output. We're basically throttling down here if we're within 20,000 meters of our target periapsis there, so we're throttling right down to 10%. And then if we're between 10,000 and 11,000 meters for our periapsis, we're going to set our throttle to 0, which is off. We're going to lock our steering to retrograde, and then we're going to just basically jump into time warp here until we're around 40 seconds from our apoapsis. We're just going to give it 10 seconds to turn in the correct retrograde direction and step up to the moon circularized function. This is a very simple function now. We are just going to set the throttle to full, and when our ship periapsis is less than 8,000 meters, we are going to switch the throttle right off and move into the next step. This is our inclination adjustment now. So basically what we want to do is come in here, we want to get our ascending node longitude, we want to make a decision here basically. So the code here is making a decision as to whether we need to lock our steering to the descending node or the ascending node. Now, of course, it depends on how far away we are from each one. So this here basically makes that decision. After that decision is made, we wait for 10 seconds. And after that 10 seconds, it'll actually re-loop around and end up in this else condition, in which case we are then just basically warping to the point where we need to do our ascending node or descending node. So we've got a longitude difference function here, which basically calculates when we're going to pass over either the ascending or descending node, and then we're going to switch to the actual adjust inclination step there. So I won't go too far into how this is working, but we're going to basically time warp in here until we get to this adjust inclination step. So as soon as we've actually hit that step, we then set our throttle to half, which is just to try to keep it fairly accurate. And we're going to basically wait until our inclination becomes so low that it starts going back up. As soon as it detects that it's climbing again, it will actually switch out from this previous inclination. So yes, there's possibly a better way to do this to get the inclination even more perfect, but basically that's what this whole area here is doing. So as soon as the inclination is adjusted, we set our throttle to 0 and switch back into our next step, which is another time warp, until we get around to start doing our landing burn. So if we can now watch all that in progress there, you can see we have time warped around till the phase angle is correct. It then begins doing its burn. You can see the orbit transition there in the terminal readout says final, where basically we've got the script now waiting until that becomes encounter. As soon as it becomes encounter, we know that we have reached the moon's sphere of influence with our trajectory. As soon as it hits the encounter, we then throttle right down just for extra sensitivity and immediately jump into a time warp. As soon as we then get up to the sphere of influence of the moon, a decision is then made as to whether we need to do a slight radial in burn or radial out burn, which you can see it doing there. In this case, it's a very small radial in burn. It then warps down to the periapsis to begin doing its retrograde burn, and it's going to burn there until it drops right down until that periapsis is less than 8,000 meters, which it's coming right down to very rapidly here. You can see it coming right down. And there we go, 7,500 meters. We're now time warping around to do our inclination adjustment, which is going on right here, right down to an inclination of 0.05, and it's time warping now to do our landing burn. In this stage of the script, we're then jumping down until we are getting close to our target, which is obviously the moon tower there. So we're going to lock our steering to basically point retrograde. We're then going to calculate the geographical distance. So this little function here is quite handy, this calc distance function. So we can check this and basically see if we're less than 48 kilometers away from our target. Then we're going to stop our time warp, and then when we are less than 28 kilometers from the target, we are going to set our throttle to full throttle and switch to our next step, which is the actual moon landing burn. Now you'll see here one of our variables is called impact distance, and we're doing the same calc distance function call, but this time we are comparing it from the actual moon land target to our actual impact distance with the trajectories mod, and we're using that exact same function that you saw above. This time though, we're using the position of our impact distance as read out by the Trajectories mod. So then we have a target direction, which basically calculates the direction that we need to turn our vessel to bring those two together. So essentially what direction do we need to burn to bring our impact distance down to 0. And essentially now, because we know these two things, we can lock our steering to the target direction minus 180 degrees, which basically means that we're not heading towards it, we're heading away from it, so in a retrograde direction. So that's how that works there, and we're locking the steering there to the horizon so that it burns nice and flat. So now we've just got a couple of conditions here. If our impact distance is less than 600, we basically throttle right down to 0.3, which is 30% throttle. And then if it's less than 200, we turn our throttle off and we switch to our next step, which is actually waiting for our suicide burn. Here we're basically just locking our steering now to surface retrograde, which is a simple little function that I've got in the function library there as well. And actually, if I show you some of the functions we've got here, this one in particular is basically the ship velocity surface vector, which is built in, and we can multiply that by -1, and that will give us the opposite vector, which is obviously retrograde. So yes, we're doing that there. Again, if you want to have a look at any of those functions, you can. Once our altitude is less than 5,000 meters, we're switching our lights on. We're then setting our hover loops and things, our hover target, our maximum steering angle, which is basically how far the vessel can pitch while it's trying to land. So yeah, these hover PID loops are quite interesting, and they're fairly complicated. I'm not going to go too far into this right now, but basically there's a whole bunch of PID loops which basically keep track of how much throttle you need, how much you need to tilt towards a target to actually move in a certain direction, all that sort of thing. And they're updated by a bunch of other supporting functions, such as this one here, which will just update the steering angle that you need to have to move towards the target. There's this hover target we can set, there is a hover altitude we can set, there's a bunch of other things that we can use here which are quite handy. So yes, some of these are just good initial things to do when you're setting your initial sort of control, how you want to control the vessel when it's coming down. And different vessels with different thruster weights need sort of different settings. So there's a little bit of trial and error there, but the rest of this function library is quite cool. You can sort of have a bit of a browse through it and just check out what some of those things do. So yes, here we're just setting some initial settings on how we want to actually get to our target, and then we're just switching to the suicide burn step, which is actually a really bad name because it's actually not even attempting to do a real suicide burn. What we're doing here is using alt radar, which is basically our distance from the surface of the terrain, which is quite handy if you're not using sea level. And yes, we're setting our maximum descent speed depending on how close we are to the ground. So obviously it's pretty obvious, I think, what that's doing. Basically, if we're getting close to the ground, we want our descent speed to be less. Again, I'm calculating the geographic distance between ourselves and the target, and we're doing this to essentially figure out when we should decide we're going to touch down. So if our ship pitch is greater than 80 and our ground speed is less than 3 meters per second, then we're going to decide to touch down just right where we are, setting our hover altitude to just below the surface, 10 meters below the surface I was going to touch down. Otherwise, we hover above the terrain by 40 meters. Now, the only thing is we don't want our ship to start tilting towards the target until we're getting quite close and our vertical speed isn't too high. So if our vertical speed's above 80, what we want to do is lock the steering to just surface retrograde still. And if our vertical speed is less than 80, we then go into our final landing, which will basically start using our update hover steering function, which will basically lock the steering so the vessel is automatically steering towards our landing target. So yes, after this, all we need to do is check to see if we still have an impact. If we do have an impact, it means that we're still off the ground. When we do have an impact, that basically means we can switch our step to end and end the script. Now, the end function is actually right down the bottom. We'll skip over all this booster return stuff. So you can see there, our end step basically sets our throttle to 0, deploys all of our ladders and things, and basically ends the loop and kills the script at this point. So yes, this is a common ending script that's used for our main booster landing as well. So all of this code here, all of these steps are for the booster landing. So we actually, on the initial phase of the mission, we don't even end up going into these booster loops at all. We actually skip over all those. So yes, if we demonstrate all this now, you can see we're jumping in, starting off the retrograde burn here. So this is now starting our actual moon landing burn. And you'll see there the impact distance is reading down. You can see it dropping there below 20, below 15. kilometers. And yes, the idea here is to get our impact distance right down, so we're just overshooting the moon tower target here by just a few hundred meters, or in this case it was 149 meters. So the ship is now basically waiting until we pass an altitude of 4,000 meters, then it's going to start doing its landing burn here, which is really just wiping off our velocity till we get to less than 80 meters per second with our vertical velocity, and then the script will basically start running those PID loops to update our steering direction and all that sort of stuff, and updates our throttle, and does all this automatically until our vessel is very, very close to our target geo position coordinates. As soon as it gets very close to that, everything ends, our ladders come out, and that is basically the end of the script. So that's the entire first part there, and we now get to head to our booster return script to actually show how all that works. Now all we do with this script is change our initial starting step, and we run the same program again. So we're starting here at the booster return step. Now, I'm not actually sure if this is the correct thing to do, but I needed to set the steering manager torque factors all up, because otherwise the booster just would not turn correctly. So yes, I've boosted all these up. I don't know if that's the right solution, but that seemed to work for me. And then I'm just setting the steering to point in the retrograde direction and turning RCS on. And then we just jump into the next step of the program, which is basically to calculate our orbit angle. And we mix this with our geodist function, which determines how far away we are from our target. And we jump into a time warp until we are around 60,000 meters from the target there. And our orbit angle is less than 55. I'm not sure if that's the best thing to do again, but that seemed to work for me. So then we jump into the next phase of our script. We basically turn our ship retrograde and set our RCS on. We just need to do a small burn until we drop into the atmosphere, until our Trajectories mod has been able to kick in. So yes, as soon as we hit 360 kilometers there, we set our throttle to full, and we just wait now until we can detect an impact on the surface with our Trajectories mod, and then we jump to the next step of our program here, which is basically then going to continue on where we left off. We're still throttled at 100%, but now we can actually calculate our impact position and make sure we're burning towards the target correctly. And that sort of thing. So yes, you can see we're setting our target to either the VAB roof or the launch pad. In this case, we will use the VAB roof. So you'd want to comment out the launch pad target and altitude there. So we're using the VAB roof, otherwise the next launch pad variable sets would actually override these. So yes, we're obviously heading towards the vehicle assembly building at a certain altitude, and there's now a series of steps just to make sure we don't burn up as we enter the atmosphere. So as we pass an altitude of 22 kilometers, we basically want to reduce our ground speed to less than 1,350 meters per second. So we actually do a burn here, and again, because we're still overshooting our target so much, what we want to do here is set our throttle and yes, basically pitch to around 20 degrees, which is about where our pitch would normally be, and this is going to make sure that we're getting closer and closer as we reduce our velocity. So at this point, we're going to burn just enough to stop from burning up, and then we are going to cut our throttle here when both of those conditions are met. So then in this same loop, this same step loop, the other thing we're controlling here is our air brakes. So basically, as soon as our ground speed is less than 1,700 meters per second, we're switching our air brakes on. Otherwise, we switch them off, so that way they won't burn up there. So yes, the brakes essentially control the air brakes by default as well. And now we only need to wait until our booster is just over 2 kilometers to our actual target, which is the VAB roof, and then we switch into our booster landing burn, which is just going to reduce all of our remaining horizontal velocity, or the vast majority of it anyway. So again, we're using these common things, and I've rewritten these simply so that you can see each step working in its isolated form. Obviously this could be rewritten so that we're just using common steering lock commands, but then it becomes harder to demonstrate. So basically we are going here full throttle until our impact distance is less than 150 meters, and then we're then basically setting up our hover target and our hover loop just so that they're ready to start firing when we get close to the vehicle assembly building. So obviously before our impact distance is around that 150 meters, we're setting a couple of different throttles. So obviously if our impact distance here is less than 300, we set our throttle right down to 20%. just so that it's not going to overshoot it too much. Otherwise, we're setting full throttle here just to bring that impact distance right down really rapidly. Actually, this code is kind of all written upside down here, so it's just a little harder to sort of diagnose. But yes, this condition here will actually send us into our booster landing step, which is basically just kind of very much the same actually as our landing script for when we were landing on the moon. So yeah, the only difference is we're setting up some different angles, angle limits and horizontal speed limits. So we're only allowing 5 meters per second, and that's because this booster is hard to turn. It needs a long time to turn back and forth to actually point towards a target. So if we overshoot that, the thing will just wobble back and forward. So there's kind of two conditions here. There is basically the condition which is met if we're very, very close and basically want to start landing the booster. I do have a more complex descend script here because we need the descent speed to really slowly actually throttle down until we're touching the launch pad at around 0.5 meters per second. So we can only touch down at that velocity, otherwise the whole vehicle assembly sort of explodes. So that's why this is kind of more complicated than you'd sort of expect. Otherwise, what we actually want to do is basically descend really rapidly. We don't want to spend too much time up, obviously way above the vehicle assembly building. So the max descend speed there is set to 100. So it's only if our distance is less than 10, our altitude's less than 300, our ship pitch is greater than 85, and our ground speed is less than 3 before we're ready to touch down. That basically means we're right above the launch pad and we're not moving very fast. So yes, obviously the rest of the loop is all about just updating our hover steering, checking whether we have an impact, and then again setting our step to the end step, in which case we throttle down, we break out of our loop, we unlock our steering, and that's basically again the end of the program. That pilot main throttle is important sometimes, otherwise sometimes it will throttle back up on you after you've left the script. Basically there's a pilot throttle setting which will be the same as whatever it was when you first started the script. So we're just watching this sequence now where we've obviously finished our time warp. We're now doing our booster retrograde burn wait. And obviously it takes a long time to turn this booster, so there's a fair bit of wait time there. We then wait until we are 360 kilometers from the target. We then start our burn, and then we push that impact distance down to around 15 kilometers, just so that we're overshooting the vehicle assembly building by quite a way, because remember, we still need to do a re-entry burn as we get to 22 kilometers above the surface. So just starting the burn there now, and you can see the air brakes also come out at almost the same point. That's more coincidental than anything, so that's they're set to come out at 1700 meters per second. And then it's just basically going to wait until we're within just over 2 kilometers of the vehicle assembly building. You can see the impact distance coming up there as we burn. And then the booster is just going to keep enough throttle on to basically keep ourselves falling at a fairly consistent rate. We want to fall fast, and actually the footage that I took here, I must have had my max descent speed set at 80 rather than 100 like I showed in the script before, but yeah, so there's not much difference there. As soon as our altitude is only 30 meters above the vehicle assembly building helipads there, we then switch into our PID steering loops. And yes, I have my more complicated descent script just touching the surface there super gently. And there we go, that is the booster landing. You can obviously then reload the script and do the exact same landing just on the launch pad with the launch pad coordinates. So yes, I hope you enjoyed that video. As I mentioned at the start of the episode, all of the scripts are available to download. They're in the description. I hope you enjoyed that, and I hope that's inspired you to go and write some cool scripts of your own, because it's super fun to do this sort of stuff. Of course, this is the way things work in the real world. Nobody's manually flying SpaceX rockets to get up into orbit. These are all automated by very, very clever, much more clever scripts than this one, but very clever scripts. So yes, this is a great skill to use. If you did enjoy this video, please do share it around. All of your support is just awesome. If you have any questions for me, please whack them down in the comments below. If this video has earned your subscription, welcome to the channel. And for all my existing subscribers, thanks for being so awesome. We will see you all in the next video.